A 50-watt light bulb is left on for 12 hours. Find the total energy converted by the bulb in both kilowatt hours and joules. So what this problem is asking us to do is convert between power and energy based on the amount of time the system is operating for. And so we'll start by listing those givens. We were told that it's a 50-watt light bulb. You should recognize that watts is a unit of power, and in electrical engineering the symbol for power is capital P, so we'll write 50 watts. We were then told it was on for 12 hours, so T equals 12 hours. So those are the two givens. We're going to have to use a conversion calculation here. I showed those in the last video. We'll get to those in a little bit. But moving on, we want to find the total amount of energy both in kWh and the energy in joules. The solution. So the key to this problem is knowing the relationship between power, time, and energy. It is a linear relationship where energy is power times time, right? You probably remember that power is the rate at which energy is converted, E over T, so that's where that formula comes from. E equals P times T, or P is equal to E over T, right? Just doing a little substitution there. We're trying to solve for E, so this here's the formula we want to use. E is equal to P, which was given as 50 watts. And the time was 12 hours. So if I take watts and multiply it by hours, I get watt hours. So 50 times 12 is 600. And then I've got watt hours is the unit. Sometimes people write it like that, sometimes not, but that's what it looks like today. And we wanted the answer in kWh, so remember that a kilowatt is times 10 to the third, so I need to move this decimal place 1, 2, 3 places. So that's equal to 0.6 kWh is the energy. So now we need to calculate that in joules, right? And we can know the conversion between kWh and joules. We used that in the last problem. 1 kilowatt hour is 3.6 times 10 to the 6 joules. The question you might want to know is, where did that come from? And the answer is that since we're in hours here, we need to do an hours to seconds conversion. The base unit of power is joules per second, and this time was in hours. So that's where the 3.6 times 10 to the 6 comes from. Is there are 60 minutes in an hour and 60 seconds in a minute, so I need to multiply by 60 times 60. So I'll show you how to do that. If I want to know E, it's 50 watts times 12 hours. So same setup as before. Power times time gives me energy, but I don't need my power in hours. I need it in seconds. So 1 hour is 60 minutes, so that's one conversion. And then the next conversion is that there are 60 seconds per minute, right? And so I can see hours cancels here, minutes cancels there, so I've got 50 watts times 60, no units, times 60 seconds, right? So I'm going to get 3 zeros, and then 6 times 6 times 5 is 180. So I'm going to get 180,000. Oh, I forgot the 12. Excuse me. So I need to multiply that by 12. So 2160000. So 2,160,000 watt seconds. Remember, a watt is a joule per second, so that's 2,160,000 joules. We normally wouldn't write that, so that's 1, 2, 3, 4, 5, 6, 2.16 times 10 to the 6 joules is the energy contained there. So kind of the long way around there, but hopefully it helped demonstrate the base units of power, the watt being a joule second, in the conversion between hours to seconds.